Hi friends, now we will have an introduction to artificial intelligence. Artificial intelligence or AI is the branch of computer science that tries to build machines which can carry out complex tasks without human intervention. For this, the machines will be able to perceive and reason. The desire to build machines that mimic human behavior has a long history, but the modern field of artificial intelligence had its origins in 1950 when Alan Turing, who is considered as the father of AI, published the article Computing Machinery and Intelligence, in which he proposed that machines could be programmed to exhibit intelligent behavior. Even though this field is in its infancy, some astonishing results has been produced, especially in the field of gaming theory. In fact, artificial intelligence or AI is the study of how to make computers do things which at present people do better. This definition provides a good outline of what constitutes AI and avoids the philosophical issues that dominate attempts to define the meaning of either artificial or intelligence. Some philosophical issues. Now the problem areas of AI are the domains that require only specialized expertise without the assistance of common sense knowledge. There are expert systems in everyday operation throughout all areas of industry and government. These systems try to solve partially or completely significant practical problems which previously required limited human expertise. But the early works were focused on formal tasks like game playing and theorem proving. Another area AI focused on the sort of problem solving called common sense reasoning. It includes reasoning about physical objects and their relationships to each other and reasoning about actions and their consequences. As a result of research in AI, perception, natural language processing, problem solving in specialized domains such as medical diagnosis and chemical analysis were attempted. Perception involves interpreting sights, sounds, smells and touch. Action includes the ability to navigate through the world and manipulate objects. But perception of the surrounding world is crucial. Animals with much less intelligence than people have more sophisticated visual perception than machines. These types of tasks involve analog signals which are very noisy and large number of things must be perceived at once. The ability to use language to communicate ideas is perhaps the most significant thing that separates humans from other animals. The largest part of human linguistic communication occurs as speech. Written language processing is easier if it is written in unambiguous characters than processing speech. We use language in a variety of ways in different situations that no single definition of understanding is able to account for them all. In order to understand sentences about a topic, it is required to know a lot about the language as well as a good deal about the topic to recognize the unstated assumptions. The specialized tasks which can be served by the artificial intelligence techniques include engineering design, scientific discovery, medical diagnosis and financial planning. AI techniques. AI technique is a method of exploiting knowledge that should be represented in such a way that the knowledge captures generalizations. It is not necessary to represent separately each individual situation. It should be understood by people who must provide it. It should be modified to correct errors and to reflect changes in the world and in our view of the world. It should be used in many situations even if it is not completely accurate. It should be used to help overcome its own bulk by helping to narrow the range of possibilities that must usually be considered. The AI technique must be designed so as to preserve the constraints imposed by the AI problems. But there will be some degree of independence between problems and problem solving techniques. However, the AI problems can be solved without using AI techniques, and AI techniques can be used to solve non-AI problems. The three important AI techniques are search, use of knowledge, and abstraction. Search. It is a way of solving problems for which no more direct approach is available. If any direct techniques are available, they can be embedded into a framework. Use of knowledge. It is a method of solving complex problems by exploiting the structure of the objects that are involved. Abstraction. This technique provides a way of separating important features from the many unimportant ones that would otherwise overwhelm any process. It is not possible to give a very precise definition of an AI technique. AI programs are easier to build using languages that have been designed to support symbolic rather than numeric computation. Lisp has been the most commonly used language for AI programming. Another language used for AI programming is Prolog. When AI comes into the conventional programming world, AI systems are being written in general purpose programming languages like C. Intelligent agents. The realm of artificial intelligence is large and merges with other subjects such as psychology, neurology, mathematics, linguistics, and electrical and mechanical engineering. An agent is a device that responds to stimuli from its environment. Most of the agents receive data from the environment through sensors and affect their environment through actuators. Microphone, cameras, air sampling devices, etc. are examples for sensors. Some of the commonly used actuators are wheels, legs, wings, and speech synthesizers. The artificial intelligence aims to build agents that behave intelligently. The actions of the agent's actuators must be rational responses to the data received through its sensors. To obtain more intelligent behavior, higher levels of responses are needed. In order to adjust the actions according to environment, the agent should possess higher levels of knowledge. Hence, the storage, updation, access, and application of real-world knowledge become a challenging problem in artificial intelligence. If the agent's responses improve over time as the agent learns, it can be considered as procedural knowledge or declarative knowledge. Procedural knowledge is to learn how, and declarative knowledge is learning what. Procedural knowledge involves a trial and error process by which an agent learns appropriate actions. The approach used here is to punish for poor actions and reward for good ones. Acquiring declarative knowledge takes the form of expanding or altering the facts in an agent's store of knowledge. An agent must be able to extract information from the data produced by its sensors to initiate responses to stimuli. This is called ability to perceive. But perceiving speech and image is a tiresome process, and in some situations, the agent must generate speech to be compatible with their actuators. Now we may see an agent that will provide a solution to the 8 puzzle. 8 square tiles labeled 1 through 8 would be mounted in a frame which is capable of holding a total of 9 such tiles in 3 rows and 3 columns. Among the tiles in the frame is a vacancy into which any of the adjacent tiles can be pushed, allowing the tiles in the frames to be scrambled. The problem here is to move the tiles in a scrambled puzzle back to their initial positions. The agent to solve this puzzle has the form of a box equipped with gripper, a video camera, and a finger with a rubber end so that it does not slip when pushing something. When the agent is turned on for the first time, its gripper starts to open and close as asking for the puzzle. When this scrambled 8 puzzle is placed on the gripper, it closes. Then the machine's finger lowers and begins pushing the tiles around in the frame until they are back in their original positions. Then the machine releases the puzzle and turns off itself. The behavior of an agent is judged by observing the input-response patterns. These two approaches are performance-oriented and simulation-oriented. Maximizing the performance of an agent is performance-oriented, and trying to find out how the responses are produced is simulation oriented. The researchers in linguistics are interested in learning how humans process language and operate in simulation oriented mode. But the researchers in the field of natural language processing are interested in developing systems that can manipulate natural languages like document translations, and machines responding to verbal commands operate in performance oriented mode. The Turing test. The Turing test proposed by Alan Turing has been served as a benchmark in measuring the progress in artificial intelligence. This proposal was to allow a human called interrogator to communicate with a test subject by means of a typewriter system without being told whether the test subject was a human or a machine. Here the machine should behave intelligently so that the interrogator can't distinguish it from a human. To conduct this test, there will be two people and one machine. The person who plays the role of interrogator will be in a separate room from the computer and the other person. The interrogator can ask questions by typing and also receive typed responses. The interrogator tries to determine which is person and which is the machine. The goal of the machine is to make the interrogator believe that it is the person. If it succeeds at this, then we can conclude that the machine can think. A well-known example of the Turing test, the result of the program Dr. or Elisa, developed by Joseph Wiensbaum. It is an interactive program conducting a psychological interview. Some of you might have experienced it. The computer plays the role of the analyst while the user plays as the patient. The purpose of developing Doctor was to study the natural language communication. Internally, Doctor restructures the statements made by the patient according to some predefined rules and directs them back to the patient. For example, as a response to the statement, "I am tired today," the doctor replies as, "Why do you think you are tired today?" instead of "Go on" or "That is very interesting." Doctor projected the image of comprehension so strongly that many who communicated with it became compliant to the machine's question and answer dialogue. Hence, the doctor passes the Turing test. The other examples which pass Turing test include internet viruses that carry on intelligent dialogues with a human victim to trick him into dropping his malware guard, and computer games such as chess playing programs. The robot dogs that project adorable personalities by tilting their heads or lifting ears in response to a sound are examples of intelligent robotics. Perception. Understanding the input from the senses to exhibit intelligent response is called perception or perceiving ability. Perception involves interpreting sights, sounds, smells and touch. Action includes the ability to navigate through the world and manipulate objects. If we want to build robots that live in the world, we must understand these processes. Most of AI is concerned with only cognition. We will simply add sensors and actuators to them. But the problems in perception and actions are substantial in their own right and are being tackled by researchers in the field of robotics. Two main challenging aspects of research in perception are image processing and language processing. Image processing. An image is recognized using an optical character reader, but it has a limitation that a certain degree of uniformity for the style, size and orientation of the symbols are required. The bit pattern produced by a physically large character does not match the template for a smaller version of the same symbol, even though the shapes are the same. So, it has increased difficulty while trying to process handwritten material. Another approach of character recognition is based on matching the geometric characteristics rather than the exact appearance of the symbols. This involves two steps. First, extract the features from the image being processed. Second, compare the features to those of non-symbols. But minor errors in the image can produce a set of entirely different geometric features as between a 3 and an 8. The task of understanding general images is usually a two-step process of image processing and image analysis. Image processing refers to identifying characteristics of the image, and image analysis refers to the process of understanding the meaning of these characteristics. Image processing involves various subjects. One is edge enhancement, which is the process of applying mathematical techniques to clarify the boundaries between regions in an image. It is an attempt to convert a photograph into a line drawing. Another activity is smoothing, which is the process of removing imperfections in the image. Smoothing keeps errors in the image from confusing the other image processing steps. Image analysis is the process of determining what the identifying components represent and what the image means. Region finding is an activity in image analysis in which those areas in an image that have common properties such as brightness, color or texture are identified. There are numerous problems associated with general image analysis. Language processing. Another perception problem is that of understanding languages. It is the process of a computer extracting meaningful information from natural language. In theory, natural language processing or NLP is a very attractive method of human-computer interaction. Natural language understanding is sometimes referred to as an AI complete problem because it seems to require extensive knowledge about the outside world and the ability to manipulate it. Whether NLP is distinct from or identical to the field of computational linguistics is a matter of perspective. The Association for Computational Linguistics defines the latter as focusing on the theoretical aspects of NLP. The success in translating formal high-level programming languages into machine language led researchers to believe that the ability to program computers to understand natural language was easy. But programming languages are constructed from well-designed primitives so that each statement has only one grammatical structure and only one meaning. But a statement in natural language can have multiple meanings depending on its context. To reveal the meaning of a statement in natural language, several levels of analysis is required. The first one is syntactic analysis, in which parsing is done. It has the role of identifying the grammar of the statement. Another level of analysis is called semantic analysis. It tries to identify the action, the agent of that action, and the object of that action. The other levels of analysis is context analysis. At this level, the context of the sentence is brought into the understanding process. Another area of research in natural language processing concerns an entire document rather than individual sentences. The two categories of problems to be considered here are information retrieval and information extraction. Information retrieval refers to the task of identifying documents that relate to the topic at hand. An example is finding the sites related to a particular topic from the World Wide Web. The current state is to search for keywords, but this often produces false leads. A search mechanism that understands the contents of the site is to be considered. This leads to the techniques called semantic web. Information extraction refers to the task of extracting information from documents so that it takes a form that is useful in other applications. The system makes use of several templates. Semantic net is a large linked data structure in which pointers are used to indicate association among the data items. And it's time to summarize the session. This module gives an introduction to the world of artificial intelligence, which makes the computer systems to behave with sense. It takes intelligent decisions with the help of knowledge it acquired through learning. This module refers to the various techniques used for solving artificial intelligence problems and describes about the intelligent agents. The Turing test is mentioned here, and two of the challenging problems such as the image processing and language processing are explained. Before moving to the next session, Please try to answer the following questions. What are the different types of intelligent actions that might be made by an agent? Explain Turing test. List the various techniques used in AI. Explain any of the challenging problems in AI. Hope you enjoyed this session. See you next time. Until then, goodbye. Take care.